Welcome back, party people. We're going to pick up on pick and pick all and pick by and see how far we make it today. So pick is pretty useful. If we start with the type signature, we're taking a list of keys, and here we're also passing in an object with key values. So it's going to get the key from here. That's going to be the K, and it's going to return another object. So it returns a partial copy of an object containing only the key specified. If the key does not exist, the property is ignored. So no undefined or weirdness, it's just ignored. Um, this is a pretty simple one. Let me grab their example here. All right, so we pass in an array of keys. So we're passing in A and D, and here we've got A, B, C, and D. So it's going to get the value of A and the value of D. No, I'm sorry. It's going to give us the actual object. So we want a partial object. So we give it this object here with four things, and we just want these two properties. Um, so we'll get an object back, not an array, but an object that's just basically like a shorter one. It's almost like a filter for objects. We run that, we get A1, D4. If we just going to change it here, if we ask for E and F, which do not exist in our object, we're just going to get back the one that does exist. So pretty straightforward there. It says see omit and props. We've already looked at omit. We looked at props as well, but it's very related. So I'm going to just do a quick one, quick review. Here in props, if I did r dot prop and it takes an array and I did oh props with an S. Yeah. So if I did an array of A and B, it's just going to give me the values. And what did I get B for? B is 2. I said A and B. Oh, props. Yeah. The prop is for one, props is for more than one. Did I save it? Did save it, so I'm doing something wrong here. Do props, access to multiple prop, array of keys in, array of values out. Arrays of values in, arrays of values out. Oh, huh, there. Um, I haven't passed any data. There we go. Okay, so now, yeah, I get one and two because if you're asking for the props, it just gives you the value. But if you do pick, it gives you the key value. So that's the difference between those two. And then if you do prop, you just only pass in one thing. You don't pass it as an array, you just pass it as a string or a number if you're trying to get the property of an array, which are numbers. Yeah, so that's a quick review. So pick, prop, and props, they're all very closely related. Uh, let's go over here, clear that, clear this, and move on to pick all. Now, if we look at the function signature between the two, they're exactly the same. So similar to pick, except that one includes a key undefined pair for properties that doesn't exist. Oh, that this one, sorry, okay. Similar to pick, except that this one includes a key undefined pair for properties that don't exist. So here, the property is ignored. So let's go back, undo. And here we want A, E, and F, but E and F does not exist. And if we log it, we just get the one that does exist. But if we do pick all, we get the properties we specified, but it says undefined for each of those. So if that's your use case, pick all will do that. Um, Otherwise, the exact same. Both added in the very first version of Ramda. And then this says see also pick, what we just looked at. So I think that covers pick and pick all. And then pick by, we're throwing in a predicate function as well as the key value, and then returning a key value. So this one returns a partial copy of an object containing only the keys that satisfy the supplied predicate, right? So let's grab their example. Clean this up a little bit. So is uppercase is going to be our predicate function. And so this is taking a key and a value. But this is something. This takes a value and a key instead of a key value. And I'm seeing this a lot in Ramda, and it can trip you up. So the value comes first, the key comes second, even though we generally say key value pairs. And when we write an object, we write the object with the key and then the value. But here it's swapped. So we're going to check when we pass in an object, it's going to check if the key, when you uppercase it, is the same as the key. So that way we know if a key is uppercase or not. And in this example, the second A and B are uppercase, but these are not. So we should get back um, these last two, capital A 3, capital B 4, because they are satisfied by the predicate. So save, run it, and we get this. So if we make this one, now we've got duplicate keys, we get the last one. The last one wins, which is typical in Ramda. That seems to be the decision they made. So they say CL filter. So this is also like we're basically filtering by that. We could probably do this with filter. Let's try it real quick. R.filter is uppercase. But is uppercase is going to take two values. So we would need to say, what we would need to do, actually taking an object. I think we could just restructure it like that. And then that's so each time it loops, it's going to loop through the key values of this because filter, I believe, um, works on objects as well. I know map works on objects in Ramda, so we're going to find out. Yeah, and then we need our data. Let's see what happens. Boom, blows up. Can't read values undefined. Oh, but see here, the key is first. That may not be the reason why. Um, but let's see. Yeah, that's not save it. Yeah, that doesn't work. Um, I'm interested though. If I did return this, what's going on? I see. Okay, so it's uppercase. It's returning a Boolean. I wanted to see the values. I wanted to log the key and the value to see what I get. Oh, okay. So do it here. Return that. Actually, it doesn't even matter because it's not working. But if we log the key and the value, what's it getting? Yeah, it's undefined. R dot filter is uppercase, but it's not getting the values in here. Yeah, because it just doesn't do that because it's filtered. But if it was map, yeah, we get the keys at least. And actually, I think this might be backwards. I don't know. The point is that this is not straightforward, but pick bias, and that's why it exists. Still messed up though. Maybe I'm messing up the whole time. Memory properties undefined. Oh, yeah, because I swapped that. Yeah, B4 and A3. So yeah, similar to filter, similar to pick, just because it's like pick with a filter, with the predicate built in. So that's pick by. Let's clean up. And now we've come to pipe. And pipe is left to right composition, otherwise the exact same as compose. And so we're not going to go through it because compose was part of Chris's original series on Ramda, and he did quite a deep dive in it. But let's just read. Yeah, I mean, at this point, if you're reading this series, you know what currying is, you know what pipe and compose is, you know filter map and reduce. At least, if you don't know those functions, then I recommend doing a deep dive into those specifically, how they work, not just in Ramda, but just how the concept of those functions and or methods. Um, the key things to remember is that when you use a pipe, the first argument, which is a function, can have any arity, but the remaining arguments must be unary, right? So you can start with a function that takes three arguments, but all the next ones need to have one single argument. And of course, if you needed more than one argument, you would just need to pass that argument as like an array or an object, some sort of complex type that you can pull those values out of. And in some libraries, this function is named sequence. And I don't know I've never seen that before, but that's good to know. And the result of the pipe is not automatically curried. So, um, the result of the pipe is a function that you call. The pipe is basically just taking one or more functions. Obviously, it would be pointless to do one function. So let's just say more than one function, stitch them together into one more complex function. And of course, this. whole series is called Pipe Dreams because for me, I basically take the smallest functions I possibly can. Some of them are already implemented in Ramda, and then I partially apply them and get them to a point where I can put them in the pipe. And then I basically call that pipe function or call the function that the pipe returns, and that gives me the result that I'm looking for. So the whole idea is to try to get things into the pipe, or in rare cases, compose if you want to do right to left composition. Sometimes there's a reason why it makes sense, I think. Um, but otherwise, we're going to move on because we've used pipe so much, and we're going to look at pipe width. And pipe width has this like really gnarly type signature. So let's read the definition first and then get back to it. And notice that this one does not have a code example. And so I'm thinking about creating a code example and trying to submit it as a pull request because I think that um, every function here in the docs deserves at least one example. So this performs left to right function composition using a transforming function. And that's the same as, well, no, actually, that's different than pipe. Pipe doesn't use a transforming function. Pipe uses just functions, like any function that you want to stitch together to create a larger function. The first function may have any arity, the remaining functions must be unary, and that's the same as with pipe. Note that the result of pipe width is not automatically curried, that's the same thing, and the transforming function is not used on the first argument. When the first argument, I believe, would be the, oh, I don't know. And it says, see also and then, which we looked at, that's for promises, compose with the right to left version of this, and then pipe, which we just looked at. So now I am confused as to how to demo this. Performs right left to right function composition using a transforming function. So let's look at this. So the first argument is this transforming function that takes anything and returns anything. And then the functions to pipe, and then it returns a function. So I bet you if we looked at, let's grab all that and throw it here. And then let's go to pipe and grab all this. Wow. Okay. So we've got that function. This is pipe. That's not helpful at all. Okay, here's the return value. So the return value is a function that takes any number of arguments and returns a z, like our pipe value. Okay, and this is our first function that takes any number of arguments because the first function in a pipe can be variadic, but each additional function takes one argument, right? So this one will return an O, that one takes an O, returns a P, the next one takes a P, returns a Q, blah, 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 until you get to one that returns an X. This one takes an X and returns a Y, Y to the Z. So, we're just flowing through the pipe, taking, passing an initial value, doing something to it, returning that value. That's the input of the next one, blah, blah, blah. And eventually you get this function that stitches all these together that goes straight from your arguments to Z. So basically straight from here to Z, that's what you're going to get back. And it doesn't take an array. Now, pipe width, it looks like takes an array. Here's my pipe width. Yeah, it takes an array of functions. But otherwise, you've got the same thing going on. So, like, everything here is the same except for the functions you're piping are an array. And before that, you pass in a what do they call it? A transforming function? Using a transforming function. All right, so armed with that information, let's give this a go. So we're going to art up pipe width, and oh, that's the log function. Yeah, here we go. Pipe width. So transforming function, right? So how about we do multiply by 2, right? So r dot multiply by 2. That'll be our transforming function, and then we need an array of functions. So I'll pass in numbers as my array, and we will r dot inc, and we'll just do 2. We'll do r dot inc and r dot uh, uh, wait a second. If I'm passing in multiple arguments, I won't be able to increment that unless I map them. Let's r dot map using increment to map, and then we'll sum them. R dot sum. And what would that do? Yeah, so it looks like this may not work because it looks like we're going to performs left to right function composition using the transforming function. So I'm wondering if this is going to call this function in between each thing, and I think it kind of will. So let's see if I get an error. I don't get an error, but I'm also not passing in any values. So let's pass in our d dot list, which is an array of 1, 2, 3, 4, 5. We've looked at that's coming from the sum data. So it's just d dot list is an array of 1 through 5. Let's see if that blows up. It gives us not a number. If we did r dot identity, so that our transforming function is just passing the value through, this should work. We get a function back. We get a function back. I wish there was an example. Um, okay, so the transforming function, which is identity, an array of functions, and it returns back a function. All right, let's simplify this even further, and let's just increment twice. And then let's pass in a value. I mean, not a value, but like a number. Get rid of the looping. We still get a function back. And it does say it returns a function. And it also says something about it's not automatically curried. So what if we pass it here, like another argument? I don't think that's going to work. No, it doesn't. Um, okay, so let's just take this let's call this pipe with without the R and pipe with 32. Yeah, we get 33, but it's only incrementing one time. So maybe the identity is always the identity of what it is. So let's go back to that. Do some more complicated function there. We get an error. Type with this not a function. I'll take this out. There we go. We get not a number. Interesting. But you know what? This is partially applied. Let's do this one as ink. And then let's do map. Let's just make them all ink. Let's all increment. See, just see what happens. Get a not a number. Okay, I'm just thinking. Okay, it does say the first function may have any arity. So can I do sum and then an array? One, two, three. Then I get an error. Reduce list must be an array or iterable. That is an array. So when it says first function, maybe it means the first function in this array of functions, not the transforming function. At this point, I'm just kind of guessing around. I get not a number there. Yeah, I'm gonna have to throw my hands up unless compose with has an example. And it does. Okay, let's use this. Thank you for having an example. All right. Okay, so there's a compose with. Compose while not nil. And I think that's a very good example, but we're going to pipe while not nil, pipe with. And anytime you see a function that ends with the word with, it typically is a decorator function. It's a function that takes a function and adds more functionality to the function. Sorry, last sip of coffee. So we're going to take the function and the result, and if the result is not nil or the result is nil, we're just going to pass the result back. Otherwise, we're going to apply the function to the result. So this is basically a guard. So you're not trying to apply a function to undefined or null because nil means undefined or null. Uh, okay, so let's just run this, make sure it's working. Gotta log it. Goodness. We'll get there eventually. All right. Saved it, running it. We get undefined. Is that what we were expecting? I think it has to do with, oh, well, yeah, we're going to need to change the order because we're doing left to right composition now. And I did just notice something that makes me realize why my previous attempts with pipe pipeWith didn't work, but let's see if that works. So yeah, we get two, and that's what we're supposed to. So we're getting the value of the prop age, which is one, and then we increment it. But we're doing this while not null or while not nil. So if we change that to null, we get null because we're just passing back. It's nil, so we're just going to pass back the result, and we get null. But notice pipe on not nil, we've partially applied this. So I should be able to take this, pass it in here, the first argument. No, too complicated. I don't have enough room here. Uh, and that's fine. Yeah. So if I did this as age 32, get back 33. Yeah, and that's actually pretty useful, to be honest with you, because this prevents you from checking if the function or the value that you're piping ends up being null at some point. You probably want to like short circuit. And there is a function called reduced, which it doesn't reference right here. But yeah, so I'm just trying to think of what's the order. Like age, what if we got the age, like if I make the age null, this first function runs and it doesn't work. So obviously it's checking the value first. No, no, it's grabbing the age first, then it's running this. So it's taking r.prop age as the function, and our result is going to be I'm trying to think how does it get the result first though? Like it would have to run this and then it can't run on the first time. Does it mention that? The result of pipeWith is not automatically transforming function is not used on the first argument. There we go. So it has to get the first argument and try it. And then, based on that, it works on the following ones. Right? Okay. So like if we did, how could I simulate that? Get the age and it's 32, then we want to increment it, but I want like yeah, the age is going to be, but let's do this. Why don't we just say r dot always null and then try to increment it. and we get null. Yeah, we get the thing back. So yeah, that I can't really think of another reason why you would use pipe with other than checking if something is null or undefined. If anybody can think of something, please leave a comment below. But at least we figured it out. And when these things are crazy, you've just got to break them up. Just zero in on one thing at a time. Because even though this looks really complicated, everything that's complicated is built from simple things. So just try to reduce it down to its simplest parts first, and then put them back together over time. Yeah. So we covered our picks and we covered our pipes, and then we'll pick back up with pluck in a separate video, though. So thank you for spending your time with me. Tell a friend, and I'll see you in the next video.